Hi everyone, this is Sharan here. Welcome to my channel. The topic that we are going to cover today is various operations of an array. So we are going to consider both integer array as well as Unicode string array, and we are going to see the various operations that can be performed on all these arrays. So the first one that we are going to see today is bitwise operation. So here what happens is when we pass an integer, so the script will convert it into an binary representation and will do the bitwise operator accordingly and produce the results. So the final results, like when we pass an integer as an input, the final result will also be an integer, but will be an outcome of the binary value. And the second one would be various string operations. So what happens when we try to add a particular string or append a particular string into all the Unicode string elements in a particular array, or when we try to multiply, like what happens, like does the length of the list of elements, does it increase or does it multiply with each and every element that we are going to see in detail, and how to capitalize or how to convert from uppercase to lowercase or lowercase to uppercase on an array which has an Unicode string as its elements. And after that, we are going to see about various mathematical operations that can be performed on an numerical or an integer array, such as addition, subtraction, multiplication, division, or power, whatever it is, like various mathematical operations that can be performed on an array. And finally, various stat operations. So here on an array, we are going to see how to compute like the average, mean, median, mode, as well as various percentile value. So in case of one-dimensional array, how to get these values, or in case of two-dimensional array or multi-dimensional array, how to get all these values on a specific dimension or a specific axis, and so on. So in today's session, we are going to see about all these various operations, and we will be exploring about how these work in one-dimensional, two-dimensional, as well as three-dimensional array, so that you get a comfort of using all these functionalities on any type of array. That's it for today, and let's go into the tutorial and go into the details of each and every one of them. Today we are going to see about the usage of various operations using the NumPy library in Python. So the first one is the bitwise operator or binary operation. So what we are going to do is first we are going to import NumPy as usual, because as these functionalities that we are going to cover are all part of a NumPy package. So the first one is we are going to do an bitwise operator or like binary operation across two integer. So first let me just print and show you what the values are. So now what we are going to do is we are going to do an and or operation between two numbers here. So the numbers are 10 as well as 11. So what happens is when we use an bitwise operator, so bitwise or bitwise and operator, what happens is whatever values that we pass, the integer value or decimal value, will be converted into an binary representation, and the operation will be done on the binary representation, and the final value will again be displayed as an integer based on the binary results that we get. So in order to see what happens, what we will do is we will do an bitwise or and bitwise and operation, and then let's see what's happening. So let me execute this one. So here what's happening is we have two numbers, we have 10 as well as 11. The binary representation of 10 is 1010, whereas the binary representation of 11 is 1011. So when we do an bitwise OR operation, so what happens is it will do the OR operation like at the first place, second place. This is an 4-place binary representation. So at the first place, the units place, so it will do an OR operation, like if it has 1 in any one of the values, like it will be picking up as 1, and so on, and then it does the same like for each and every digit in this binary representation. So as you see, the bitwise OR operator for these two numbers based on the binary representation of values, the output is 11, So when you use the binary representation for it, like it is 1011, which is nothing but these two are 1, so the result will be 1. So here both are 0, so it's 0. So again here both are 1, so it's coming up as 1, and here it is 0 as well as 1 here. And since we use OR operator, like this will also be 1. So 1011, which is nothing but 11. So when we do an bitwise OR operation on 10 as well as 11, the result is 11. Similarly, similarly when we do an AND operation, what happens is the first place, the units place here. So we have 0 and 1 here. So since we use AND operation here, what happens is the binary operation, like the AND operation between 0 and 1 will be 0. So in case of AND operator, like maybe if you can refer, if you are not very comfortable with all these binary operation, you can just, it's a simple concept. You can check online like what happens when you use OR. Like both needs to be 1 in order the results to be 1. So when you use OR operation, when you use AND operation, both needs to be 1 in order to get a result of 1. So when you use an OR operation, what happens is even if one of them is 1, so then the result will also be 1. So that's how the bitwise binary operation is. So here is another example, like for a different number. So maybe you can practice this with some numbers to understand that what's happening, how an integer is converted into a binary representation. So you can check these online. Like these are all not very important, but these are all some key mathematical concepts that will be helpful. Like these are all the basics, like how an integer is represented when in binary format. Like it's good to understand about all those concepts and how an bitwise operator would work. So the next one is moving on to the string operation. So in string, when we use and, for example, here we have two strings here. So both of them are Unicode string format. So when we use AND operation and pass on these two string arrays, let's see what's happening. So when I execute this, so as you see here, what's happening is the elements between these two string arrays are added, and then it's becoming 1. Like for example, here we have only A at this position, and here we have X. When we add two string array of same length, what happens is each and every element within that string array gets appends with each other, like the value. Like for example, if we have A1 here, and when I execute this, so what happens is A1 appends with X, and then it becomes one element. So like when we pass two string arrays as input, after the AND operation, it becomes 1, where like the elements and the elements of these array are added to each other. So maybe let us see what happens when I try to add two string arrays of different length. So as you see here, what happens is when I try to add two string arrays of different length, it's not able to do the operation, because like since it is doing these additions at an element level, it needs to be in exactly same length. So maybe when I add one more element here, so then now when I execute, it should be working fine. So that's something that we need to take care of. And as you see, the data type here is Unicode string of length 3, because that one of the element is of length 3, and it automatically picks up this as the data type. So what happens when we do an AND operation between an array as well as an character? So here we don't have two arrays, like we have only one array and we have one character here. And when I do an AND operation between these two, what happens is this particular element here will be added or will be appended to each and every element of this particular array, the one in the top. So when I execute this one, so as you see here, what happens is the first array and then the character that we specified here gets added to each and every element in the first array. And the data type is changed to Unicode of length 2, because like they are all of length 2. So when we do multiplication, like let's see what's happening. So when I execute this, so what's happening is when I use multiplication, like each and every element within that particular array is multiplied or is getting repeated that many times. So when I use 3, what happens is each and every element within this array is repeated 3 times. So maybe when I use a b here, and re-execute this. So what's happening here is, so the value, the element that is present in this array here, it gets repeated 3 times. Like we can see AB is getting repeated 3 times, and each and every single element in this array is getting repeated 3 times. So if I do 4 here, what would happen is each and every element would be repeated 4 times. It's just copying itself and repeats later the number of times that we pass here. So that's how an multiplication would work on an string array. The other the string operations that are actually like commonly used would be like these ones. Like for example, if we have, let's say, a value which is all in lowercase, and then we want to capitalize, like when we use capitalize, what happens is the first character alone will be capitalized, whereas everything else will be remaining same. So we can use capitalize. Like as you see here, what happens is this is an value. So when I use capitalize on these on this character, what happens is the first character is capitalized in this particular string. And let's say we use the same function on an string array. So here the string array 1 is nothing but this one here. So let's see what happens here. So when I execute this, so what happens here is we have made some changes to this string array 1. So this was the final value that was present in the string array 1. So when I capitalize the string array 1, what happens is in each of and every single element, the first character is capitalized and everything else remains as it is. The other ones are converting from lowercase to uppercase and uppercase to lowercase and so on. So here NumPy dot character char, because like it's an Unicode string array, and when we use dot upper, what happens is every single element will be capitalized. So here, so all the values of this particular array here are capitalized here. So when I use maybe lowercase, what would happen is so every value will be converted into lowercase. So even if there is any capital letters that we have passed on as the input, it will be converted into lowercase. So the other string operation that would be really useful in a real life data science project would be this one. So here when we have a list of elements, and each element has some empty string appended to it, like before and after. So this is a common issue, like mostly when we work on a legacy systems, the data formats might not be exactly perfect, and it generally would have some empty strings later before the actual value as well as after the actual value. So as you see here, there is there are some empty spaces like before and after this string, and we don't want these empty spaces. We want to remove, and then we just want to pick up the actual value. So what we can use is we can use dot strip functionality. What this would do is this would remove all those empty strings, and then it will just pick up the actual value. So when I execute this, what you can see is so this was the original array, and now all the empty strings like before and after the characters are removed, and we just have the values. So there are a few more additional functionalities in strip later. We can use it for removing the empty strings just before the value or after the value, like however we want to implement. So when we use just strip, it will by default remove all the empty strings like before the start and after the end. And the other string operation is replace. So let's say we want to replace a particular value with a new value. So here the string array 3 that we use here, it has the value, this value. So we want to replace x with a. So when I use replace, what happens is whenever this x value is found, the x value is replaced with a. So here we are still seeing the empty string because like I just used a strip for printing it. I haven't saved it, so the original array is still the same as what we have passed. It isn't. We haven't removed those empty spaces. So that's why like you see all these empty spaces here. But the key point here is whenever the value of x is found, it will be replaced with a. So let me see that I am going to give a value that is not present in this array. So let me execute this one. So now what happens is you are not getting any error, but because like it will try to look for this particular value. When this value is found, it will be replaced with a, but when this value is not found, nothing happens, like it remains the same. So whenever you are going to use all these replace functionalities, you must be very sure about what is the input that you are going to pass, and then we need to be sure that it is what is being represented in the actual data. Yeah, so these are all the various string operations. So far we have seen how a binary operation would work, and string operations like how to append some character, or how to make a copy of each element and make it repeated like a certain number of times, as well as how to change the case, or how to replace a value, how to remove all those empty strings before and after the actual value of a particular element. So now next one is we are going to go to the mathematical operations that are generally performed on an NumPy integer array. So here we have two arrays, like array 1, array 2, and these are all the list of values that are being stored in these two variables. Let's see what happens when we do addition, multiplication, and subtraction on these arrays. So I'm just going to execute this and then show you what's happening. So as you see, when we use plus operator, what happens is that each and every element of these two arrays are added to each other. So 1 plus 2 is 3, right? It's coming up as 3 here, and each and every element will be added. So if I try to add like one more additional element to this one, so what would happen is it will not work, because similar to all the string operation too, like whenever we try to do some string operation on two arrays, those two arrays should be of same dimensions. So if it is going to be two-dimensional array, it's not a problem, but the two inputs that we are going to pass should be exactly of same size. And yeah, in case of multiplication, what would happen is each and every element will be multiplied. So 2 into 1, 2 into 2, 4. So that's how you see the value here. And subtraction is the first array minus second array, and the resultant would be coming up here. So whenever we use all these mathematical operation, it will be done at an element level, and the key point here is we need to ensure that the dimension as well as the shape and size are exactly same between the two arrays that we are going to use. The other ones that are commonly used are round off. In some cases, like in the real data, like especially on the financial data, it would have a lot of decimal places, like values with a lot of decimal places. And whenever we want to do the round off for any specific calculation, so we can use NumPy like np.around. So what it will do is whatever the array that we are passing here, each and every single element of this array will be rounded to the decimal that we are specifying here in the parameter. So there are also floor as well as ceil operation that can be performed on an integer or numeric array. So this is the floor. This is the functionality to use floor as well as ceil. So let me execute and then show you what's happening. So as you see, the first one, in case of round off, the values will be rounded to exactly the number of digit that we have passed on here. And so if you see this particular value, it is 9.546, and when we try to round it off to 2 digit, what happens is it becomes 9.55. So here we are not dropping off the numbers after that specific decimal point that we have identified, but we are actually rounding it off to that decimal point. And in case of floor, what happens is whatever value that we give here, so any value after the decimal point will be ignored, and the value before the decimal point will be retained as the floor value. In case of ceil, it's exactly opposite. So it's kind of like a ceiling. So whatever value that we pass here, like for example, if it has something that is 2.01, it will consider the higher end value, which will be the closest higher integer. So from 2, the closest next integer is 3, so it becomes 3. So similarly, 6.23 becomes 7, 7.34 will become 8, and so on. So these are all various mathematical operation. The other one is power. So when we use power and pass 2 array as input, so what would happen here is so when I execute this, so it becomes 1 power 2, and then the value will come up here, and 2 power 2, whatever value will come up here, and so on. So all the values of this array is specified as 2. But now instead of passing on an second like value as an array, we can pass on that as an simple integer. So if I pass the value as 2, what happens is each and every element will again, like, it will be exactly same as passing 2 as the value for all the elements in this array. It will operate like very similar to that one. So when I execute this, you will see the output is exactly same. But what's happening is we need not repeat it, we need not create an array, just we use an integer, and it will make sure that each and every single element of the first array will be raised to the power of the value that we are giving here, and then the resultant will be the new array. So that's all about the various mathematical operation. So mathematical operations are very common when we are going to use when we are going to do like any mathematical operations on a numerical array. So this will be very common, like for example, when we have image data, so we would have multiple matrices of values, and maybe this could be useful in those cases where we have various matrices and we want to do the operations for between those matrices. And moving on to the next one, the final one, that is various statistical operations that can be performed on the data. So here are some of the statistical operations that can be implemented. So the first one is identifying the min as well as max in an array. So when I execute it, so what happens here is, so this is an two-dimensional array. So we have 3 rows and 5 columns here. So when I use just numpy mp.min, so what happens is the most minimum value in this particular array will be identified, and then we are printing it. And same with maths as well, like a.maths. And if in case we want to identify the min and max on a specific axis, so let's say with this one, like what I'm doing is I'm passing this additional parameter, which is the axis. So here what happens is when the axis is 1, so it will be it will identify all the like row wise. So maybe before doing this, let me print and show you the actual array. So as you see, this is how the array is. It has 3 rows and 5 columns. When I use min and then when I pass axis as 1, what's happening is it is identifying the minimum element across each and every row. So what we did is we get an one-dimensional array, but it is like the minimum value of this particular row and second row and third row and so on. So when we use axis as 0, the same thing is performed, but it is performed on column wise. So we can also pass this as axis is equal to 1 and axis is equal to 0. So when I execute, it is the same one, like the values will remain same. By default, when we don't give axis, like it will still be considered as an axis. So this parameter will be still considered as an axis. When we give an value that is out of bound, like for example, this is a two-dimensional array, and when I give value as 2, which won't be existing. So when I execute it, it will say that axis 2 is out of bound for array of 2 dimensions. So it should be either 0 or 1. So maybe you can try out all these operations, and then maybe try these operations on different sets of data and then understand what's happening. So the other ones are like identifying the median. So it's similar to what we have done here. So what I'm doing is I'm using the same array, identifying the median across the axis 1. So the output should have 3 values here. So yeah, we have 3 values. So it will be like for each and every single row, the median value will be identified and then picked up. So here the median values in this row is identified as 3, here 8, and here 13. And the other ones are like average, mean, variance, and when I execute it, so for the same array we are able to get the average, mean, and variance across the axis 1. So when I change this to 0, what would happen is it will do the same thing but by column wise. So we can see that the number of elements has increased because it is doing these operations on various columns like 1, 6, and 11. Between these, the average, median, and variance or mean and variance have been calculated. And the final one is about identifying the percentiles. So So on this array, I'm saying that I want to identify the 70th percentile across axis 0. So what happens is the 70th percentile for each one of those values are identified. So here, since the axis is equal to 0, what it will do is it will check this particular row, check the 70th percentile, and then picks up that value, and that's how the array is getting generated. You can see that the output here is not exactly found in the array in the input that we have. So for example, here, since the axis is equal to 0, what happens is the range of value is 1, 6 and 11. So 1 will be considered as 0th percentile, 11 will be considered as 100th percentile, and the 70th percentile value will be identified, and so that value need not be actually present in the array, but whatever is the 70th percentile value, that will be picked up here. So when I pass on the value as 100, so what would happen is, when I execute this, so as you see here, the 100th percentile is nothing but the value that we specify here in the last row, because that's the maximum value. So all those values will be picked up and then will be represented here. So that's how percentile would work. So you can maybe when you execute it, you can think like why the values that are not part of the array are coming up as an output. It's actually, it will consider the first value as 0th percentile and last value as 100th percentile, and whatever percentile that you specify, the values according to that percentile will be picked up and then will be coming up in the output. So that's it for today. So maybe what you can try to do is, you can try to come up with your own 1-dimensional, 2-dimensional and 3-dimensional array, and try to repeat all the topics that we have covered so far. So these topics that we have covered so far should be good enough. For example, specifically on string operations, the one that where we use to convert lowercase to uppercase to lowercase, and capitalize, as well as removing the empty spaces. So those things will be commonly used in most projects, as well as the numerical operations. Whenever we have a matrices of information, like numeric matrices, and we want to do various operations, the one that we have covered in the numerical operators will be very useful, and the stat operations are also useful to identify various percentile value or the average values across and a numerical array. So I hope you have learned something new today. If you have learned something new, please give a thumbs up and subscribe for more or similar data science related content. So this video series is about learning data science in 100 days. Please stay with me. The first 40 to 50 days will be about the foundational blocks, like where I will be covering about the Python basics, pandas, NumPy library, statistics, and visualization, and various other foundational blocks. So once we cover all these foundational blocks, then we will be moving on to the algorithms, where we will first go through the algorithms and maybe try to pick up a project and implement the algorithm end to end. So stay tuned and keep learning. See you on the next session. See ya. Bye.